All right, we're here with Team 3663 CPR at the Pacific Northwest Clackamas event. We are super excited to show off their robot. They have a really slick arm that's been doing really well today, and a climber that they're eager to talk about, along with some really sweet code that controls all of that. So we'll go into all of that and more on this episode of Behind the Bumpers.
Yeah, so over here we have our 2025 robot, and overall this year we decided that we wanted a really simple and robust robot. Of course, this year with the game, it was a little harder to make it simple with all the complexities of the game, but we did our best to make sure that all of our mechanisms were as simple as possible and that we were able to score efficiently and hopefully win the competition. And I'm going to pass it off to our software leader.
Hi. I think one of the fun parts about this bot was being able to figure out different positions of scoring, being able to score all the way from L4 to L1, being able to score different algae in the processor and in the net. This bot has been really, really cool to work with. Altogether, it's been cool to just work with different collision avoidance things, because although we're trying not to run into different things like the reef, we're also trying to make sure that the arm doesn't go into the belly pan. Those were cool calculations to work on this year. And also just making sure that we're placing everything exactly how we want to, and different speeds at different levels. Yeah, this bot has been really cool in just the complex and the simple ways that it was designed. I'm gonna hand it off to Isaac.
All right, so I'm going to talk about the arm and the grabber. So the reason for our design was initially we wanted a pass-through bot, but we didn't think that a pass-through through the elevator was ideal for our team. So for the grabber and the arm, this is actually our 4th iteration from our design standpoint. So we wanted, again, a pass-through, so we have a sideways elevator, and then we mounted the arm onto the carriage, right? So we also, for our first iteration, we had belts outside of the arm, which we were a little concerned about the robustness of the arm, because the belts could get stuck potentially on like the reef or something. So for the 1st to the 4th iteration, we decided to put the belts inside of the 2x2 aluminum and to run our wrist and our grabber. So the reason we also did this was for our center of gravity to become as low as possible. So our arm intaking would be like this, and then coming out and scoring on the reef would be somewhat like this.
Can we actually see the arm do that?
Isaac, you're gonna want to catch it.
And we're gonna see the algae as well. All right,
so that was our algae in the net and our coral on the reef. So I'm gonna pass it on to Joey now to talk about our climber.
When we saw the original game, we found the deep climb to be very important for the ranking point. We wanted it to be as simple and take up as small of a space as possible. So we decided to move the pivot point up. We saw from other teams that latching into the cage would be the best for grabbing into it and being able to move the cage up to have the center, the chain in the middle of the robot. And we had to design it around the battery so it could counteract the weight of the elevator. We have a latch system that latches into the cage, and it flips up and moves the center pin around here, and the arm comes down out of the way of the climber.
And do you have any like ratchet mechanism, or is it just gearing that holds it in the air?
We originally planned on having a ratchet that would keep it in place, but we ended up being able to use just the gearing to hold it up for long enough.
Thank you, 3663. It's been awesome getting to talk to you all. I'm excited to see how you do with the rest of the day, and good luck.